to another episode of Tech Unscripted, where we talk all things tech and AI with some of the industry's leading experts. Today's podcast is sponsored by AI Elevate Partners. We help companies overcome inconsistent lead flow and unpredictable revenue by leveraging AI-powered growth systems so they consistently close more deals without increasing headcount or burning out their team. Most of the time, our clients come to us frustrated with their inconsistent sales results, as businesses typically come from referrals and word of mouth, leading to unpredictable sales pipelines and struggling to grow at scale. But with the right strategy and support, they're able to grow their MRRs by as much as 50% with 6 to 12 months while shortening the sales cycle. If that sounds like someone you know, check out our website, aielevatepartners.com, or just connect with me on LinkedIn. Now let's dive into today's episode. Today's guest is a real treat and an industry veteran with a very unique background, and I'm excited to welcome Todd Wright, COO and President of Performance Building Solutions, and excited to dive in. Todd, if you can take a moment, introduce yourself to our audience and give us a little background on how you came to where you are today, leading Performance Building Solutions.
Great. Thank you, Jillian. Really appreciate you having me on today. It's been a long road for a farm boy originally from Kansas, raising Black Angus cattle, but spent quite a few years in the building industry, and actually started out looking to become an architect and got involved in computers, CAD/CAM systems, and then that started my career really in business and information technology. Spent about 32 years in the IT industry, so got a really fantastic experience in that industry at a great time, right? Going from punch cards all the way up to today with AI, right? So it's really been a phenomenal journey. And that journey actually took me around the country, took me to Brazil for 15 years, where I lived and worked there, got to see not only the tech side of Brazil, but also the construction side. And I've always been interested in construction and architecture, and always been involved in it, my whole life, and built with a variety of different building technologies, right? Systems, materials, and methods. Moved the family from Brazil to Orlando, Florida in 2015, and ran across this little company in Melbourne, Florida, who was trying to do some great things in the area of light gauge steel framing. And I'd really never been involved with construction using light gauge steel framing. So this was kind of my first exposure to that, and realized that it was quite phenomenal product to be using. Became a client, then became an employee. And now, I'm a founder and part owner of a Performance Building Solutions. And that's what we focus in is in construction, utilizing light gauge steel framing technology. And through that process, we actually developed our own patented building technology based on light gauge steel framing. And that technology solves one of the major issues with light gauge steel framing, which is called thermal bridging. And so we have to stop that heat or cold, depending upon where you are, what climatic region you're in. We've got to stop that from coming into the building, so the buildings become higher performance, more energy efficient. And it's one of the main reasons why the building industry has not adopted en masse light gauge steel framing, because the ductility is very high for steel, right? So it transfers cold and heat very well through those studs of the building, right? Through the walls of the building. And that makes them inefficient from an energy consumption perspective. So that's always been one of the main challenges with using light gauge steel framing. And so we've developed and ultimately patented a technology that creates a thermal gap on the outside of the walls and thus eliminates thermal bridging. And with that inventive step, we're able to actually use light gauge steel to build energy efficient green homes. So it seems simple, it seems somewhat maybe irrelevant, but that little gap that we can put on the outside of the building transforms structures to the point where the same building in the same spot built traditionally versus our system could actually reduce the energy bill from 60 to 80%.
Wow.
So it really is the difference between green building and traditional building when you're talking about light gauge steel. So that's really been our focus since 2012, like I said, as an employee of the company. And we've been looking to try to find better ways to essentially increase the performance and the resilience and the durability of structures, whether that be a home or whether it be a large commercial building or a multifamily building. So that's really what our company is doing today. It's what we're all about. And we're just trying to promote green, energy efficient buildings, and buildings that, like I said, are more resilient. They have a higher performance, they last longer, and so they create more value add in the market. And for that owner operator of the building, we're driving down those, the OPEX, your operating cost or your total cost of ownership, we're driving that down. And there's a variety of ways in which we can do that, but we can unpack that a little bit if you'd like to.
Yeah, and I'm very interested first, I think just defining what green building is versus a traditional build. I think it'd just be beneficial for the audience to just understand that from your perspective and how that has transformed what you guys are doing with the late gauge steel and that thermal barrier. If you could talk a little bit about that.
Yeah, I think that, my take on it, and like I said, is my opinion. A lot of the green building initiative, whether you're looking at the ESG perspective, was really focused on, the environmental impact, right? And of course that's important. We cannot have, and we talk about like environmental sustainability, right? Green building. We're talking about the materials, right? Being eco-friendly, but we also are looking at the performance of the building as far as it reducing the use of our natural resources, right? And the other resources, electricity, conserving water, impact on runoff, and then of course the durability and resilience of the actual materials. So the term's, I think, overused quite a bit, but we have to take a more holistic approach, right? When we're looking at designing and engineering and building a structure. When you look at, if you get into the carbon footprints and the whole ESG sort of conversation globally, structures and houses they really represent the highest carbon footprint of any other category, right, in the world globally. So our buildings need to be energy efficient. So when you're looking at, for example, the life cycle assessment, they call the LCA, or your environmental product declaration, when you're involved in getting, for example, LEED certification or the EPA's Energy Star, the building that you're going to engineer and build needs to meet higher quality, higher criteria, right? In a variety of different categories. When you get into LEED, for example, they're even looking at how far away did the raw materials come from their source to the job site. And you're going to make or lose points, right? If you're bringing everything from China or India or whatever, and you're importing everything, you're not going to get as many points as if that product was made down the road or in your state. So they're looking at a variety of different things when they're looking at the environmental impact of that building as a green building. Okay. But in my opinion, and vision as far as where we're going, we cannot have environmental sustainability at any cost. You look at some of the green initiatives, it's like there's just a blank check, there's unlimited budget, right? But in reality, I mean, that's not sustainable either. Right. So, what we really need to be looking at is the environmental aspect of sustainability, but also the financial sustainability combined with what's good for the local community. So it's kind of like a triangle, right? Environmental, financial, and community. And if we can check those three boxes with what we're doing, then we're achieving true sustainability, okay? And, a perfect example of that would be the affordable home market around the country. And of course, there's different terms. Like I said, I use affordable home market, right? So, you're having many builders trying to focus on building those houses as cheap as possible, right? But when they're done, they're not energy efficient. And then a family, a low income or, lower income family may move into that house, but they can't afford to live in it because the electric bill's so high. So they're getting these, quote, affordable homes, but they're unaffordable for the operator because they were only looking at the affordability from the build perspective, not from the operational perspective. And that's what we need to do. We need to change our perspective and on how we're looking at construction in general. It's not only about the build cost, it's about the operational cost.
So how do you think you drive some of those behaviors so it is that three-legged stool or that triangle that you're saying, that balanced approach, as opposed to, I think you mentioned LEED and EPA and some of those kind of leading industry standards, and the measurement around that doesn't necessarily address that kind of holistic. How, from your perspective, how do you change that?
Yeah, well, that's a good question. I equate it to like a salmon swimming upstream. It's a long, hard road, right? Because you're trying to educate the entire ecosystem, right? From the client to the architect to the engineer, the general contractor, the trades, the building department, the appraiser. So you're having to interact with this entire ecosystem and really educate all of them. And there are different initiatives at different levels in these individual trades, right? But it's not easy. And what we're doing is just one house, one structure at a time. Everybody that's involved in that, just educating them, showing them that there's a better way. And then when it goes back to the impact on the affordability side, our technology, it's called Kratos, by the way. And so our Kratos building technology really addresses, let's say, the core or root cause, right? If you were to do a root cause analysis of what's going on and why of the equation. And that is, we're really looking at the bones of the structure. So if you don't have a good, solid, energy efficient shell or building envelope that's going to withstand the test of time, that's going to make it energy efficient, then, you're already going down a path that it's not going to end well. And you look at from the fires in the Palisades of California to the hurricanes in Florida, the islands, you're not going to win against Mother Nature ever, right? But at least we need to try as much as possible to increase the resilience of these buildings. So, you look at the light gauge steel framing, which is the bones of the structure, and then the materials that we wrap that structure with. Like, for example, magnesium oxide board. It's fire resistant, impact resistant. There's no organics in the building. And so that's one of the things we're also trying to do. Like I said, we're looking at holistically at that building. It's not just the steel frame. They're building 100% steel frame in Australia. They've been doing it for years. They can't build in wood there. So there's other countries that are way ahead of us, but you can't only stop at the steel frame. If I take a steel frame structure and I clad that with plywood and the roof with plywood and the flooring with plywood, and I put standard, paper-backed drywall in the building, what have I really achieved? Is it non-combustible? No, it's not. Because we went and cladded it with wood.
So what's your solution there?
So what we do, again, we take an approach that we're looking at every single component that we put in that structure. So today we can actually build a type 1, type 2 non-combustible structure with steel, magnesium oxide board. We wrap that board, which is, just a white board, right? We wrap it inside and out. We use it for subflooring. We use it for the roof, soffits, fascias, bucking. There's no wood. There's no organics in our building. There's no wood in our building structure. So now we've reached a non-combustible classification. So what's that do to your insurance cost, right? It's going to drive that insurance cost, that premium down, because that building is now non-combustible. What about termites? There are no termites because there's no food for termites, because there's no organics. So now what's that do to the termite bond? What's that do to the termite treatments every single quarter, every year for the life of the building? What about mold and mildew? Again, no organics in the building, no mold, no mildew. It's the paper backing on your gypsum board that you're going to put in there. The gypsum board's not going to, attract mold and mildew, but that paper will. So when we build resilient and we use the right materials, we can achieve a level of performance and resilience that will far outlast any other type of building technology, right? Whether it be CMU block or poured or ICF or wood or whatever the case may be. So it's lightweight, it's strong, it's non-combustible, no mold, no mildew, no termites. And so now we're achieving a level that is going to provide the economies when you look at that TCO, right? That total cost of ownership month by month, year by year. So what we're doing there is when we provide that type of a structure, we're driving down insurance costs, we're driving down the electric bill, we're driving down maintenance. Now, with the green building classification, checking that box for the building department, that helps accelerate that process. Having that box checked also helps with green mortgages. So now they have different back-end ratios on their mortgage calculations, and they have incentives for better rates and better terms. So again, that green building technology flows through the entire ecosystem. And in theory, right, if we can get the appraisal industry up to speed, then those buildings will even appraise at higher values as well. And it's going to last longer. So that's the approach.
What, just out of curiosity though, what is the upfront cost difference? Because I foresee, obviously, there we talked about the affordability up front and at what cost, and whereas it might be affordable to build, but in the end operating it becomes unaffordable. So where's that balance? I could see some pushback from, obviously these materials I'm assuming are going to be more costly. So have you helped determine, or from your experience, where there is maybe a break even point, or how you balance that upfront investment so that you can long term have the savings from an operational and sustainability?
Yeah, I mean, that's a good question. When you look at what you're asking about really is the build cost, right? Looking at that, how do if we can unpack that a little bit. So in this typical construction budget, it'll break down in about 16 different divisions, and division 5 is the steel, right? Is the steel part of the budget. So that's where our steel framing comes in. So if you were to take our steel framing shell package and compare that to a wood shell package, yeah, we're going to be tremendously much, I mean, upwards of potentially even 50 to 70% higher, right? But what we're essentially doing in that entire construction budget is we're pulling values from other line items to apply to our line item. So, for example, one of the materials and labor that you'll typically have when building a wood frame structure is you have to wrap the outside with a vapor barrier, high vapor barrier. So our building doesn't need that. It's already impermeable. So that line item on their budget, we're going to remove that 100%. We're going to take that money, we're going to move it down to our line item. Okay. This happens throughout the budget. So you cannot look at only the framing package line item. You have to go all the way down to the bottom of the construction budget and look at the final result. And typically when we have the ability to do that with the builder, they open, a lot of times, they don't want to open those numbers up. Right. But when you're able to open those numbers up and do a more equivalent or apples to apples comparison, we will be at the cost of wood framing, and in some cases even less.
Interesting.
Yeah, because one of the things that you don't have with like the traditional wood frame house is you don't have access to the 45L tax credit. That's your green energy efficient tax credit offered by the Department of Energy. It's called the 45L form. And you can get anywhere from $2,500 to even over $5,000 tax credit per door. So we were just doing a cost analysis on a 528 door multifamily apartment. And just that one line item, we were able to achieve a $1.4 million tax credit if we built it our way. So, normal construction, you wouldn't even have that 1.4 million. And then the other thing, when you look at the build, so normally we're reducing also the time to build, right? So that particular project also, which was a 3-year project, we actually in our schedule can do it in 2 years. So now you look at what are the carrying costs for that year that we removed. what's the loss in rental income for those 528 apartments for that 12 months? So what's the interest? What's the carrying cost? What's the bond impact on the bond, the termite bond? And so we call those opportunity cost, right? So when you look at the build cost and the operational cost, you have to also look at the opportunity cost. So using the same example of this apartment building, the entire opportunity cost and savings combined on a roughly $70 million project, we actually economized $20 million. So now the numbers are completely different.
Right.
Right.
And that's arguably just from the construction standpoint. We're not even talking about the impacts at that point on energy efficiency costs or those types of things, right?
Right. And, a lot of that, depends really on whether they're building and selling it, if they're going to be the owner operators in a
Right.
BTO type environment. So, yeah, there's different conversations you're going to have in different scenarios. But when you look at reduced build cost, reduced, TCO or operational cost, and then the opportunity cost for that owner builder, the numbers all of a sudden completely change. The numbers are different. You see multifamily and other projects all over this country being shut down, or not even started because the numbers aren't working anymore, right? And then you look
Right.
at the insurance cost, then that's also phenomenal. But
So when
we
you talk,
did an energy audit on a hotel up in New Jersey, and just the energy cost from the operational side, you imagine a hotel, they got to have everything running all the time, right?
Mhm.
So that building built, they typically build these little, hotels along the sides of the interstates. They're, 3 stories, 4 stories, a couple hundred rooms. So we did an energy audit on one of our projects there, and it was savings of $20,000 a month in the energy bill. $250,000 in electric bill savings in one building, 100,000 square foot hotel. So, again, if you're talking about maybe somebody's house, they may go from a $350 a month electric bill down to $60, $70.
so when
And we
you're
have homes here in Florida that have an AC electric side bill of $30 a month.
It's insane. So when
Yeah.
you're looking at kind of adoption rates, or let's just say your area of focus for the Kratos technology and where you guys are building and selling, what type of clients is the typical customer or client? Let's
Well,
go.
we've been primarily focusing on the residential market for many, many years. And most of those clients were owners, property owners, and they were primarily all custom homes. That's a difficult business to be in, quite frankly, because it's up and down, stop and go. And when
Mhm.
you have a factory, you're trying to, once you build the beast, you got to feed it, right? So, once that factory's running, you got to keep it running. And when you're doing custom builds, it's very difficult because we're talking about offsite industrialized construction, not site built, right? So
Mhm.
we have to have enough jobs running through the pipeline to keep the factory going. So we're transitioning now to really work with production type builds. So multiple models, multiple products, and then hitting the print button and just repeating that same structure over and over again.
So shifting away from your traditional residential focus and more into that, multi-door
Yeah,
type of applications,
yeah.
hotels.
Yeah, a lot more on the multifamily side. Now, on the single family residential side, we're still doing that, but we're working with builders, architects that are like developing models, right? They'll develop either for a community, 8, 10, 15 models, architects that are developing models. Maybe they might have 10 or 20 different models in their portfolio, converting into our technology and then offering those. So that way a client can, choose from anywhere from 10, 20, 30 different products, and then they can finish the house however they want. We're just really providing the shell structure, the bones of the physical of the building, right? And then they can finish it out however they want.
So if you were to, it sounds like there's a couple of bottlenecks here from like a growth perspective and an adoption, but if you were to have a magic wand of one thing that's kind of slowing you guys down from progressing that kind of path and business in general, what would you say would fix that?
Well, I would work with you to develop an agentic AI that would do all the engineering.
There you go. Okay, so then just shifting gears then.
That's what we need to do. I tell you, the biggest problem we have today, considering that a custom home, when you go from scratch, from architectural all the way through the permit set, you're going to run anywhere from 9 to 12 to 18 months. It's a very long, arduous process. And the engineering, the structural engineering, more than the civil engineering, but in the MEP engineering, the structural engineering, it takes the longest. It's really one of our biggest bottlenecks. We can pump out several million pounds of steel out of a factory in a year. Our partner factory in Sanford, they can pump out 12 to 24 million pounds of steel a year out of their factory. So our bottleneck is really not in the fabrication of these structures. It's really in the steps that occur before that. It's in the design and the engineering, getting through all of that. And, as I mentioned earlier, before we started the podcast, we're really looking to try to implement agentic AI in some very key areas. And one of those areas is estimating and takeoff. Some companies that are beginning to develop agentic AI for that, and that's really necessary. And then the other is in structural engineering. Agentic AI for structural engineering, I think, is going to be key to really being able to drive business through companies like ours.
So how do you see the agentic AI playing a role in both those scenarios? Let's start with first the kind of structural engineering piece. What do you envision there?
Well, on the structural engineering as well with architecture, you have to work through, these professionals have licenses, right? So for you to actually submit a set of building plans to the building permit department for approval, they have to be developed and signed and sealed by licensed architects and engineers, right? And there's other licenses available in life safety, mechanical, electrical, plumbing, in other areas. There's civil engineering as well. Mm-hmm. So there's many, many people involved in this process to try to get, a structure installed on a lot. So these are areas where we can, I think, probably more realistically, we're not going to be replacing these professionals. These professionals are going to be using AI tools to speed up their processes. So today we're working on a house right now for a client in the Bahamas, and that's taken over 3 months just on the structural engineering, where with agentic AI, and of course they're having to plug everything into these 2 or 3 different software packages, right? And they're having to go through and do manual calculations, very, very math intensive, the structural engineering aspect of things, right? Where you're dealing with different wind loads, snow loads, and forces, right? Coming down onto, up against, uplifting, hurricanes, earthquakes. So there's seismic. So it's a very, very complicated process when you get into structural engineering. You can have a 400 or 500 page calculation document for a simple house. And none of it you and I would understand. It's just pages and pages of formulas. It's like, maybe you would understand it, it's way beyond me. I know enough to be dangerous on the engineering side because I work with them on a daily basis. But I think that, we're going to have to find a way to utilize AI in these processes, right? And especially in architecture and in structural engineering, takeoffs, estimating, planning, and even in project management, right? Because there's a lot of moving parts. And today you see, for example, there are companies that are working on heads up type visual systems, right? So you upload your plans into the database and you have the goggles, right?
Yeah.
You have the VR goggles, and when you walk up to a wall, you're in a building, and you walk up to the wall, it overlays all of the electrical and the plumbing and everything that goes inside that wall, what that's supposed to look like. So even in those areas, we're seeing some interesting developments that's occurring in the area of IT for job site based tools. So, you combine that with AI, and then of course, we can get Elon's Optimus robots to help us out as well. We're looking at that actually in the factory. We've been looking at implementing robotics in our assembly line, which is primarily a manual process. We're looking to actually probably jump the robotic arms and go right to the robots, because they're more autonomous. They have the dexterity that
Right.
is like a human. We're
So
looking to apply
today in your
robotics.
manufacturing process, it is very manual, human operated.
Yeah, so what we're doing is we're taking the architectural plans for a building and we're developing the structural engineering. And then from that, we take those plans and we import them into a special software that we do virtual framing. We actually build the structure virtually, right, using 3D BIM modeling. And then from those models, we generate CNC code that goes to the machines.
Okay.
So those machines are roll forming machines. And so they're going to punch out, we call it printing, right? They're going to print all the pieces to the house right in the factory.
Yeah.
Walls, the floor systems, the roof trusses, columns, beams, every single component for that shell structure gets printed right out of the factory. And then as they come off the machine, the next step is to assemble them. So we assemble those walls as wall panels in the factory. And then those get bundled up and shipped to the site. So at the job site, you're not really doing what you would consider traditional on-site building.
And that's why it speeds up the process so much. You're
By at
literally
least,
standing up the prefabricated.
that's right, at least 50% reduction in time, typically in the field to erect the shell. So to give you an idea, I had a very interesting experience. My grandparents needed a house back in Kansas. So I actually designed and fabricated it here in Florida, put it in a 53-foot dry van, shipped it to Kansas. My dad installed the foundation, right? He let me know when it was there. And then I flew to Kansas, and me, my dad, and 4 Amish put that house up in 3 days. And
Wow.
it's all tilt wall. And we'd never done it before, you know? So we started on Tuesday morning and I left Saturday morning and took a picture with my grandparents in front of the house. All the windows and doors in, shingles going on, the house completely dried in. So
That's insane.
very rapid, and we're not really compromising quality for speed, right? We get both. In fact, we get better quality and it's faster. So
Interesting.
yeah, and here's the other interesting thing, there's no dumpster on site because
There's
you're
no
not
waste.
culling and cutting the wood. I have a photo of the waste that came from that house is about 10 pounds of steel, a bunch of little pieces from cutouts, and even
Mhm.
that goes to the recycling. So, back to the green building, right?
Yeah.
Is all about,
Circle. Yeah.
right? The ecosystem, right? Environmental sustainability. One, we're using steel. It's the most recycled material on earth. Okay.
Right.
And the steel today, for the most part, is, at least here in the US, is not coming out of the ground anymore. It's recycled steel. And the steel that we use here in the States has a recycled content of higher than 95%. So we're using recycled steel. And then, of course, if you actually wanted to take the house down at some point, you're not sending it to the dump. You're not burning it. You're not bulldozing it down and sending it to the landfill. You
Right.
can actually send it to the recycling. So that's our life cycle assessment, right? Cradle to grave. And all the components are really looked at from that perspective. What's that cradle to grave life cycle assessment? So that's what we're trying to do. And steel is such a phenomenal product that this checks all the boxes.
So now you hear a lot about logistics and impacts of materials and those kind of things. Obviously, it's a recycled material, but are you seeing any impacts from your perspective on, the steel industry in general, or what's going on there?
Yeah, there's been. I mean, when COVID hit, it just collapsed our entire supply chain, right, globally. So, and we've not fully recovered from that. Just to give you an example, the steel that we use, our price per pound pre-COVID was 45 cents a pound. Okay, this is 2018, 2019. We were running 40 to 45 cents a pound for G90 galvanized steel that we use in our buildings. And it reached a peak around June, July of 2022, $1.65 a pound. And it's still today has not gone back to that. And I don't know if it ever will, but we're inching, we're inching down little by little. But today we're 60 to 70 cents a pound for steel, but it never actually went back. And then of course you've got transport, right? So the whole transportation ecosystem completely collapsed. So trying to get the drivers, the trucks, those expenses went way up. Container imports for some of the things that we use went from $2,500 to import a container from China to today it's around $10,300, $9,000 to import that same container.
Yeah.
So we're still seeing major increased cost and issues in logistics globally, whether those products are coming from India or China. Some things even our shipping cost. We have a lot of clients in the Bahamas. And so our shipping costs from the US to the Bahamas also has gone up significantly. So I don't know if these things are ever going to come back down, but it doesn't help. And it's not just steel, right? It's all building materials. Look at what happened to wood. It went from 400 to 1,600. On its rates.
Which helps drive looking at alternative solutions too, right? So I would imagine probably had a good positive impact.
Yeah. When wood tripled overnight, we were like, "Hey, that's great! Look at we're gonna be in good shape now with steel," and then steel went up.
Right.
Why are these steel mills shutting down? And a lot of them did. They got to take them down every once in a while for maintenance. And so when COVID hit, they thought, "Oh, demand's going to go down, and we got to clean our furnaces and do some maintenance." Sometimes these furnaces will take up to 6 months to heat up, right? So to shut down a steel mill, it's not an easy task, and so their downtime is significant, But the thing is that we're dealing with steel is a commodity item like wood, but its cost per pound or per linear foot is higher than wood, right? If you were to look at like a 2x4, 8 foot long may run, $2.50 to $3, right? But that same stud in an 18 or 20 gauge profile in steel at 60, 70 cents a pound is going to run you maybe about $6 to $7. So, linear foot, stud by stud, we're paying more for the raw material.
Right.
And therefore that's going to, parlay into a more expensive shell cost.
Yeah. So when you're thinking about, how do we find efficiencies in your process and, how agentic AI and robots apply into that, I mean, that has to probably factor into the overall decision-making process.
Yeah, for sure. Like I said, we're on the engineering side of things, we're looking at agentic AI in that area. In the factory, we have custom software to manage the factory specific for the light gauge steel framing industry. But we are looking at automation in the assembly process after it comes off of the machines, and then also in the spray foaming process. So there's about 3 major areas that we're looking at implementing AI-driven technology going forward. And the thing is that we're pretty far behind the rest of the world, right? The rest of the world's been building modular with pods and automation and in steel framing for many, many years. Light gauge steel framing has been around since the 50s.
Yeah. So how do we catch up here?
We just got to have more people talking about it like we're doing today, and education. The good thing is that the building codes are changing. They're becoming more stringent. And of course, there's mass movement towards environmentally friendly construction and vehicles and this and that. So we have the whole eco-friendly movement going on, and we have the building codes. We have clients that are demanding better quality, more resilient homes and structures, right? They want them to last longer. They want the energy bills to be low, and they don't want the maintenance. And I think that, these high costs that we have in insurance as well they're going to have to drive people to build better. We have to do more with less, right? We have less trades, less resources, and then we also have to do it better. So we have to build more with less, better. And then that's going to make, you look at the number of people that are leaving just in our state of Florida. I mean, they're looking at almost 300,000 people leaving Florida in 2025. Mortgage rates and values have doubled. We've had 6 carriers leave the state of Florida. And now our affordability rate just in Florida we were in the top 10 to 49 out of 50 of affordability rates.
Yeah. So while you're not really in real estate, I mean, you are very close to that. Talk to me a little bit more about, I mean, obviously we're talking about Florida, but then I think of, other natural disasters. What's going on in California and rebuilding there? And what are your thoughts about the real estate market in general? And in particular, some of these very hard impacted natural disaster prone areas.
Well, yeah, I mean, California and Florida has really been hit the hardest, right? With the fires and we had almost 9,000 structures destroyed. We were out there. I've been out there multiple times since the fires. We're working with companies out there, engineering and other companies, architects and builders to try to, provide better technology, better options for them to build with. So the thing is, out there, the whole mentality and the whole industry is based on wood. And we're seeing right now, there's over 200 houses going up right now in the Palisades, most of them all in wood. So, how do you stop the madness? It's just, you have the lobbies that are behind the wood industry. You have the building codes, you have a lot of interests that want to continue the status quo. So it's like I said, it's like a salmon swimming upstream. It's just it's a long, hard path forward. But I think we gotta keep fighting the good fight. We have to keep promoting, building better, providing more value to the homeowners and to the occupants of those buildings. I mean, even from a safety perspective, right? And a health, we didn't even get into the safety and the health perspective, but the products we use are healthy, right? If I provide a structure that eliminates the food for mold and mildew, and I'm reducing mold and mildew in that building, then now it's a healthier environment. If we're providing fresh air intake, putting in the proper HVAC systems into the building for fresh air intake, maintaining the humidity and eliminating mold and mildew, now people with asthma and other types of respiratory issues actually can live in a healthier home. So we're really addressing indirectly.
Todd, educating people, right?
Yeah. We're really addressing many, many different areas. Again, it's back to root cause analysis, right? All these things we learn in the IT world, right? You're doing the SWOT analysis, and then you're doing the root cause analysis, right? Trying to attack those, trying to solve those problems, not just treat the symptom, right? So that's what we're trying to do. We're trying to, treat the cause of the issue, not the symptom.
Yeah, well, I think you're doing a great job, Todd. I mean, I've certainly learned a lot from this conversation. I support a lot of the green initiatives, and your patent is extremely interesting. And one tidbit of information I didn't give to you: my husband is a mechanical engineer, and he in his studies did a lot with thermodynamics.
He'll love it. We gotta have a chat with him.
So phone a friend here.
You come down here to Florida and visit the factory, and we'll give you a tour and take you to some houses.
I'm sure he would get a kick out of it. And I don't fancy myself an expert, but when dinner conversations are around thermodynamics and heat transfer, then pick up a couple of things here and there, right?
Yeah. It's, for some, it's an interesting topic. For others, it's like, okay, I don't care about that. I just want my electric bill to be $50 a month, and then they're good, right?
Yeah. Well, and to the average American, that is very, very important, especially nowadays when you talk about just the affordability in general, and the full life cycle of what you guys are doing in this green building industry, and how you can translate that towards, real dollar savings for the average American, I think is very commendable. And I'm very honored to be a part of this conversation in any shape or way to educate the audience and everybody what they should be looking at.
I appreciate you having me on and even having this conversation, so it's an important conversation.
For sure. and one I hope that we continue. For the audience, how could they learn a little bit more about performance building solutions and the Kratos technology, or if they're interested in learning a little bit more about their next building project?
Sure. So they can visit us at on our website. Most all of our documents and project galleries and technical documents that's needed is on our website. So that'd be performance buildingsol.com. And then also we have a product website. It's just for the Kratos product, and it's called kratos.build, kratos.build. So those two websites, they can find most of the information. Obviously, they can reach out to me directly via email or.
Yeah, find me here. You're on LinkedIn as well, so we can find Todd
I'm on LinkedIn.
on LinkedIn. Well, awesome. Well, thank you so much for joining me, Todd. This has been, like I said, a great conversation and one that I think is truly impactful. And I'd love to watch you guys, and I will continue to follow along on your journey. So thank you.
Yeah. Well, we appreciate it. We appreciate it. I appreciate it. Thank you very much. It's been an honor.